Okay, this is 8th grade. We're starting 2-2. I'm going to do a quick review because the last lesson was all about combining like terms, and hopefully everybody remembers how to do that, because if you don't know how to do the lesson we just did, Mr. Roland, then you're going to be lost for this one. You with me?
Yes.
Okay. All right, so Mr. Roland, we have 2x plus 1/2 x equals 10. Combine the like terms, Mr. Roland.
It would be 2x, and then 1/2, that would be 2 and 1/2.
2 1/2 x equals 10. All right, Mr. Bowen, what's next? I'm going to solve for x. That's what we're trying to do. This is a review of the lesson we just did. Mr. Sabati. Mr. Holmes.
You multiply it by 10 1/2. I mean 2 1/2, mother. Right?
No. Miss Clement.
What times did you do?
10 minus 2 1/2.
No. Miss Wagner.
Since it's multiplying 2 1/2 by x, you would do both sides divided by 2 1/2.
Yeah, because remember, you want to get the x by itself. That's what we're solving for. We're solving for the x. And you guys have had it easy up till now because the x has just been on one side of the equation. Today's lesson, x is now going to be on both sides. All right? So you ask yourself, what's happening to the x? Mr. Roland, what is happening to that x?
Isn't it getting multiplied?
It's getting multiplied by 2 1/2. What's the opposite of multiplication? Division. So just like what Miss Wagner said, we're going to divide each side by 2 1/2. They cancel out, so we now have x all by itself. And on the other side, we have 10 divided by 2 1/2. So I'm going to rewrite this as x equals 10. I need to change that 10, Mr. Sabati, into what? Mr. Roland? A fraction. So I'm going to put it as 10 over 1. And now, what does that stand for, Miss Stevenson? Oh, I did it wrong, didn't I? Keep, change, flip. Thank you for recognizing that. So we keep it as 10 over 1. We change it to multiplication, and we flip it. Well, we need to change 2 1/2 into a fraction, an improper fraction. How do you do that, Mr. Sabati? Miss Durgan, do you remember? You remember how to change this into an improper fraction?
Is it 2 times 2
Is 4.
plus 1?
Plus 1 is
5.
5, so it's 5 over 2. So it's 5 over 2, but now we need to flip it. 2 over 5. Now it's multiplication. You just go straight across. Mr. Perry, what's next?
Orders of operation, or,
This is what we're doing right here. What's next?
could you do 10 divided by 5?
Yeah, you could. You could do some cross-canceling. So 5 goes into 5 once. 5 goes into 10 twice. Now what?
Now you do 2 times 2,
Which is?
4
And?
over 1,
Which equals?
4.
4. Okay. So that's what we did last week. Problems like this. Okay, so this week we're doing problems like this. Okay? And I'll tell you right now, the next lesson is even a little more complicated. But if you guys understand how to do the last lesson, you'll be fine with this. If you don't, you got a little bit of catch up to do. So I'm going to start doing these, and you guys can write them down and pay attention if you want. It's up to you. So we have 4x plus 6 equals 2 1/2 x plus 12. you're solving for x. To solve for a variable, x, y, z, it doesn't matter what it is, you have to get it by itself on one side of the equation. And last week, we ended up combining like terms. And kind of that's what we're doing here, but we have to move them over. So I've got a 4x and 2.5x. Any idea what we could do? Anybody, any thoughts on that? All right. So, what's the rule? Whatever I do on one side of the equation, do on the other. So I want to get rid of this 2.5x. I'm going to subtract 2 1/2 x. So that means I'm going to subtract 2 1/2 x over here. So I'm going to go like this. They cancel out. I'm left with, over on this side, 12. They're completely gone. 2 1/2 x, subtracting 2 1/2 x, it's gone. What am I left with over here? Well, I've got a plus 6. I haven't done anything with that. What's 4x minus 2.5 x? Yeah.
1 1/2
1 1/2 what?
x.
X, nice, good. So now I have 1 1/2 x plus 6 equals 12. So when you have the variable on both sides, you'll often have to either add or subtract it to get it to one side or the other. And it doesn't matter which side it ends up on, whether it's the left or right side, as long as the variable is by itself on one side of the equation. And we've done that now. So this should look kind of familiar. We've done problems like that. The x is just on one side. So now I want to get x by itself. So let me pull a stick here. What's something I could, what would I do here? Boy, Mr. Dickerson, the first stick I pulled was yours. Mr. Bowen, what would I do?
1 1/2 plus 6.
No. Miss Wagner, what would I do?
You would subtract 6.
Yeah, I'm going to subtract 6. That's the first step I want to do in getting x by itself. Okay, they cancel out. Now I'm left with 1 1/2 x equals, what's 12 minus 6? 6, okay. Now, I ask myself, what's happening to the x? That's what you want to ask yourselves. Mr. Scroggins, what's happening to that x? Right now, what's happening to it?
I don't know.
So whenever you have a number, and the variable, doesn't matter what the variable is. Let's say the variable is z, and I have a number next to it, okay? It means they're being multiplied together. All right, so what's happening to the x? It's being multiplied by 1 1/2. What's the opposite of multiplication? Division. So I'm going to divide each side by what?
1 1/2.
By 1 1/2. 1 1/2. 1 1/2. Okay. They cancel out. I'm all done on that side. X is all by itself. Equals 6 divided by 1 1/2. Okay. That should look familiar. I did a problem like this 5 minutes ago. All right. Ms. Turner, what would I do next in 6 divided by 1 1/2? Say again? Yeah. We're going to do the keep change flip. We're going to do change 6 into a fraction, so that's 6 over 1. The 1 1/2, we need to change that into a fraction. So 2 times 1 is 2 plus 1 is 3, and that's going to be 3 over what? 3 over 2, and we're going to change that to multiplication. I've got to flip the 3 over 2, so it's 6 over 1 times 2 over 3 equals,
You can cross cancel.
and I can cross cancel. That becomes 1, that becomes 2. 2 times 2 is 4. And just like the problem we did a few minutes ago, it's the same thing. Oh, 4 over 1. It's 4. Okay? All right. So some of the problems will just involve fractions. Some of them might involve decimals. So here we have a 0.05x plus 925 equals 0.03x plus 1,250. I want to get x by itself. So when possible, and it's not always possible, you always want to keep the variables positive. So I don't want to subtract 0.05 from this, because then I'll end up with a negative x. So I'm going to subtract the 0.03. Subtract 0.03x. Subtract 0.03x. They cancel out, equals, so I'm just left with 1,250 on this side of the equation. What is, Ms. Turner, what's 0.05 subtracting 0.03? Yeah, so we have 0.02x plus 925. Now I have x on one side of the equation. Mr. Harsh, what could I do next to solve this? Not yet, not yet. You're getting ahead of yourself. Ms. Lagarbo, what's the next step to solve this?
You subtract 925.
That's what I would do. I would subtract 925. Subtract 925. Whatever you do on one side of the equation, you do on the other. They cancel out. We're left with 0.02x equals 1,250. Subtracting 925. What's that going to be? 325. I heard somebody say it there. Where am I here? 325. All right. Now what? Mr. Perry, what would you do now?
You're or you divide 0.2 by 0.2.
Right. Divide each side of the equation by 0.02. 0.02. They cancel out. Now I have x on one side of the equation. Now, some of you could just whip out your calculator and do this in 30 seconds. But if you didn't have a calculator, and sometimes you won't have access to one, you're going to have to do it the hard way. Okay? And so 325 divided by 0.02. What would you do in that case? Ms. Herrera, what do you think? Can you divide a number by a decimal? No, you can't. So what do you need to do? No, Mr. Harsh? Yeah, you could do it that way. That's one way to look at it. He said multiply each side, both by 100. The other way is, the way I think about it is I just move the decimal 2 places over, and the decimal in 325 is right here. So I'm just going to add 2 zeros. Now the decimal's right here. So I'm going in the same direction with both problems, and I'm going to move it the same number of times. So now we have basically, what do we have here? 32500 being divided by 2. Oh my gosh, well this looks like something you probably did in 3rd grade. And yeah, it would take you a minute to do this problem, but sometimes you guys won't have a calculator. So 2 goes into 3 how many times? Once. What's left over? 1. Bring down the 2. 2 goes into 12 how many times? 6 times. Nothing left over. Bring down what? The 5. 2 goes into 5 how many times? Twice. 4. 1 left over. Bring down the 0. 2 goes into 10 how many times? 5. Bring down the 0. How many times does 2 go into 0? 0 times. There we go. So 32,500 divided by 0.2 is 16,250. Okay? Wow. That's a lot. But It's a lot of work, but I think that was a good refresher for some of you.
And I'm not gonna lie, I love figuring out how to do it. No, you just it would be one 6.
What, I'm not sure what you're asking me.
It would be 16,250.
Yeah,
Yeah. Oh, 0.2 going into.
yeah, that's a really small number going into a fairly big number. Think about it.
But it's usually 25.
Okay, we move the decimal 2 places here, and then we move the 2 places here. All right, let's look at this one. Oh, I better go quick. Actually, I'm going to jump down to 12 here, this one. Yeah, you guys are out of here in like 2 minutes. All right, so this is 6 subtracting 6x equals 5x minus 9x minus 2. All right, again, you want to get x by itself. And so I have a 5x over here and a negative 6x over here. When possible, Mr. Holmes, you want to keep the variable positive. So I'm going to add 6x. I'm going to add 6x. They cancel out. I'm left with 6 equals, what's this end up being? 11x. Oh, actually, you know what? I take that back. I'm going to rewrite this here. 6 minus 6x, I got ahead of myself, equals 5x minus 9x minus 2. Sorry about that. I have 2 x's over here. I'm going to combine these first. So I'll rewrite this as 6 minus 6x equals, what's 5x subtracting 9x? Negative 4x minus 2. Okay. Now, I was thinking, wait, something wasn't right. Now, again, whenever possible, you want to keep the variables positive. So I'm going to go back to adding 6x, adding 6x. They cancel out. 6 equals, what's a negative 4x plus 6x? 2x minus 2. Okay, now I have x all by itself. So, and I still want to get, well, it's not all by itself, but it's on one side of the equation. Now I'm going to add 2. Whatever I do on one side of the equation, I do on the other. The 2's cancel out. I'm left with 8 over here equals 2x. I'm going to pull one more stick before you guys go. Ms. Herrera, what's the next thing I do? Divide each side by 2. You can ask yourself what's happening to the x. It's being multiplied by 2. I do the opposite. They cancel out. Equals 8 over 2 equals 4. X equals 4. Another one where x equals 4. Okay? Yeah, whatever you guys got to do, you better go. I'm going to end this video.